This video is looking at the use of trigonometric identities to solve trig equations. So we've got an example here, the sort of thing you might be asked to solve in an exam, where we've got both sines, sine squareds indeed, and cos's as well. We've also got an algebraic fraction to deal with. So in order to solve this equation, the first thing to deal with is the algebraic fraction. So here we've just got part A. So we need to eliminate this algebraic fraction here by multiplying through by the denominator. So the first thing to do is do that. So we get 3 plus sine squared theta equals 3 cos theta, and multiplying through denominator eliminates it from here. Here we can expand the brackets to get 3 sine squared theta equals 3 cos theta times cos theta, that's 3 cos squared theta, which is just shorthand for cos theta, minus 2 times 3 cos theta, so 6 cos theta. Now at this point you need to recognise that there's no way we can solve this in its current form. We've got sine squared thetas and cos squared theta, and there's no way I can solve both the sine and the cos equation at the same time. So I'm going to need to eliminate one of them. Now because I've got a cos theta here as well, it makes it easier to keep this cos squared theta and remove the sine squared. Eliminate this in some way. So we need to use my identity in this way. One I'm going to use is sine squared theta plus cos squared theta equals 1. So it's really important you learn for your Formula 2. So I want to eliminate sine squared theta, so I'll just rearrange this slightly by subtracting cos squared theta from both sides. Sine squared theta equals 1 minus cos squared theta. Now I can just replace any sine squared theta with this expression instead over here. So where it's got sine squared theta, I'm going to replace it with 1 minus cos squared theta. So it's the same. I just need to simplify this down a little bit. So 3 add 1 obviously is 4. I've got negative cos squared theta here, so I'm going to add cos squared theta to both sides. That will give me 4 cos squared theta. Right hand side of the equation, 6 cos theta. Also makes sense now to divide through by 2, just to make my life a little bit easier. So I'm going to get 2 equals 2 cos squared theta minus 3 cos theta. And you can recognise hopefully this is in the form of quadratic. I've got some unknown, cos theta, and it's squared, and I've also got the unknown here. It's therefore in the quadratic form. So subtract 2 from both sides to get it equal to 0, so I can solve the quadratic. Now at this point you can, if you want, replace the cos theta with x's, so it would be 2x squared minus 3x minus 2, and solve it using the formula or complete the square. It will factorise though, so we can just put this in 2 brackets. 2 cos theta, obviously 2 numbers at the end, and multiply to make negative 2. So the one I multiply 1 by 2 cos theta to this one, and that's what the cos theta is, negative 3 cos theta, negative 2 there, plus 1 there, that should work. So you can check it using FOIL or any other method you like for multiplying 2 brackets. Therefore, there's 2 possible solutions. Either 2 cos theta plus 1 is 0, that would make cos theta equal to negative half, or cos theta minus 2 is 0, in which case cos theta would equal 2. Now the first thing to recognise is that cos theta can't be 2. The graph only goes up to a maximum of 1 and a minimum of negative 1, so this is not possible. It's really important that you do put this as a solution and then explain that it's not possible. There is no way in which cos theta equals 2. So the only solution left is this one, cos theta was negative 0.5, which the question asked me to show in the first place. To complete part B of the question, it says hence solve this equation, we just need to use the result from the first one, always that right there, hence, well, it shows up here that if this is true, cos theta is negative 0.5. What we need to recognise is these two expressions, those equations are identical, except that the theta has been replaced by 3x in all situations. Therefore, I can replace this theta with 3x. So for part B, I can just write down cos 3x is negative 0.5. Just following on the logic in the first one. So I just need to solve this equation. So I can use my cos inverse function on my calculator. If you don't know the result of this, do that and you can just get 3x equals the result at 120 degrees. There is a bit of a hint here. It says given all solutions, so you need to think why will there be more than one solution. If we sketch out the pos graph, that, so 180 degrees, 90 degrees, 270 degrees. We'll get the solution here for 120. So cost from negative 0.5. Solution round about there. It's going to be the 120 degrees. But there will be more solutions if we continue along the 0.5. There'll be another solution here. To work out that, we just need to use the idea of the symmetrical nature. The pos graph is symmetrical on this line. So if that solution is 60 below, this one will be 60 above. So 60 above 180 will be 240 degrees. So there'll be another solution there. If I continue the graph, just the end of this one here, there'll be more solutions. So it's got a period of 360 degrees. So I'll repeat every 360 degrees on from that. So I can just add 360 to this, which will get me 480 degrees. And you can add more 360 to this one as well. There'll be solution 360 on from this one, so that'll be 600 degrees. And there will be more solutions after that. So you can always add more on later if we need to. It's asking me for all solutions in this interval. So these are all the ones you need to get. Well, if this is 3x, to find your x values, all you can do is divide through by 3. 120 divided by 3 gets me 40 degrees. 240 divided by 3 gets me 80 degrees. 480 divided by 3 is going to get me 160 degrees. 600 divided by that's outside the interval. Any 40, 80 and 160. I can stop